Hey everyone, and welcome to the Explainer. Today, our goal is incredibly specific, but absolutely vital for modern security operations. We're going to build a cost-effective, lightning-fast threat detection engine right from the ground up using Microsoft Sentinel. We'll be looking at the foundational architecture that makes all of this possible, focusing heavily on exactly how we store our data, and then how we translate it so our security teams can actually use it effectively.
I mean, it's the ultimate modern SecOps dilemma, isn't it? If you work in security, you absolutely know this pain. You're constantly ingesting firewall logs, identity telemetry, cloud events, and it's coming from dozens of different vendors. The sheer volume of data is astronomical, which means your ingestion and retention costs are just sky high. And on top of that, every single vendor formats their logs differently. It's a massive, expensive, chaotic mess. Okay, let's dive into this and see how we can completely re-architect our approach to solve this exact problem.
So here is our architectural blueprint for today. First, the security data dilemma. Second, Sentinel's tiered storage schema. Third, ASIM, the universal translator. And finally, parsing, query versus ingest. Let's get right into it.
Starting with Section 1, the security data dilemma, balancing your budget with lightning-fast threat detection.
Moving right along to Section 2, Sentinel's tiered storage schema. This is the foundational layer of our architecture. Now, before we can even think about analyzing our data, we have to store it in a way that doesn't completely bankrupt the IT department, right? By routing data based on its actual utility, we can drastically reduce costs, and we do it without sacrificing the speed you need for critical security operations. Notice how the data lifecycle steps down in temperature here. We don't just dump everything into one giant, expensive database anymore. We've got a hot tier for immediate analytics lasting 30 to 90 days. Then a warm tier acting as a data lake for up to 2 years. And finally, a cold tier in archive blob storage for long-term compliance spanning anywhere from 7 to 12 years. Every single tier serves a highly specific operational purpose.
Let's look at our first specific tier and see how this builds our foundation. This is the hot or analytics tier. You can think of this as the expensive, high-performance engine room. Its main purpose is real-time detection and active incident response. Because this tier utilizes log analytics workspaces for high-performance KQL queries and live threat hunting, you're paying a premium. Because of that, we generally set interactive retention here for 30 to 90 days. Now, you can extend it up to 2 years for high-priority telemetry, but honestly, you really want to focus this tier strictly on high-value security signals, identity logs, authentication events, and active endpoint alerts. Basically, it's for the data you need to query instantly to stop an attack right this second.
Next up is the warm tier, which operates as your data lake. The purpose here is cost-effective historical correlation and trend analysis. Security analysts often need to look back, say, 6 months to see if a newly discovered threat actor was quietly lurking in the environment. Well, you definitely don't want to pay hot tier prices for that kind of search. The warm tier, which is built on Microsoft Fabric OneLake, retains data from 90 days up to 2 years. It lets you run scheduled KQL or Spark jobs without that premium price tag. So it's absolutely perfect for unified security logs, bulk contextual data, and normalized tables. It really is an incredible middle ground for those deeper investigations.
And finally, we reach the cold tier. This is essentially your compliance vault. A lot of industries mandate the retention of security logs for 7 to 12 years. Now, you are almost never going to query this data for active threat hunting. It is purely for rare audit recovery and forensic reconstruction. To manage this cost effectively, we use native Sentinel log archiving or even automated exports via Logic apps or Data Factory to push this data right into Azure Blob Storage using cool or cold access tiers. Crucially, we apply immutability policies here. You might hear this called WORM, which stands for Write Once, Read Many. The focus here is entirely on raw, compressed, low-touch compliance data and massive bulk firewall logs.
All right, Section 3, ASIM, the universal translator, turning fragmented logs into a single language. So now that we have our data physically stored in a perfectly optimized, cost-effective way, we need a framework to actually read it. Storing the data is only half the battle. If your data is sitting there in 50 different formats, querying it across your hot and warm tiers is going to be a total nightmare. So what exactly is ASIM? The Advanced Security Information Model is an abstraction layer and a structural normalization framework. It aligns with the Open Source Security Events Metadata, or ASIM guidelines. But in plain terms, it just bridges disparate data schemas. Instead of your SecOps team having to write one query for a Cisco firewall, and then a completely different query for an AWS CloudTrail event, and a third for Windows event IDs, ASIM normalizes all of them.
It radically shifts the team's operational focus away from managing annoying vendor-specific queries and moves them towards scalable multi-vendor threat hunter.
At the core of AWESOME is a classic software design pattern known as the robustness principle. It simply states, be strict in what you send, be flexible in what you accept. In the context of Sentinel, this means the system takes highly unpredictable, chaotic source telemetry from hundreds of different tools, accepts it flexibly, but then strictly maps it into uniform, highly predictable structures that your analysts can actually rely on.
And this brilliantly illustrates exactly what we mean. This mapping is the ultimate aha moment for any security analyst. Take a look at the original source log fields. One vendor calls the field src-IP, another calls it source_IP, a third just says IP address. ASIM takes every single one of those and maps them to a single target ASIM field, src-IP address. It does the exact same thing for destination ports, mapping them all to DST port number, and various user IDs get mapped cleanly to target username. Suddenly, all that chaotic noise from a dozen different firewalls and identity providers, it becomes a single, beautifully unified, structured dataset.
And because of this mapping, we can use what are called unifying parsers. Your analysts no longer have to query direct vendor-specific table names. Instead, they query a standardized schema, like _IM DNS for DNS activity, or _IM _network session. This unified approach is huge because it means you only have to write an analytics rule once. That single rule will flag a threat regardless of which vendor actually generated the original underlying log. It is a massive force multiplier for your security operations center.
Section 4. Parsing, Query versus Ingest. The execution strategy for data translation. Okay, so we know we want to use ASIM to translate our data, but pivoting to the tactical execution phase, we have a really important architectural decision to make here. Exactly when should our system apply these translations? This is the ultimate architectural showdown. We have to weigh two very different approaches. On one hand, we have query time parsing, which gives you high flexibility by applying a translation mask right when an analyst runs a search. On the other hand, we have ingest time parsing, which offers high-octane performance by permanently transforming and formatting the data the exact moment it enters Sentinel. Let's break both of these down.
Query time parsing is the default out-of-the-box method in Microsoft Sentinel. It gets executed at the exact moment an analyst runs a query or an alert fires. It utilizes KQL user-defined functions. Actually, think of it more like a virtualization mask overlaid right on top of the raw tables. The main benefit? It retains the raw vendor logs natively in your storage, and because it applies at the moment of the query, it offers incredibly high flexibility. Like, if a vendor changes their log format overnight and breaks your parser, you just update the function, and boom, the fix applies instantly to all your historical data. The downside, though, is that doing this translation on the fly results in much higher CPU consumption and definitely slower query runtimes.
Now, contrast this with ingest time parsing. This is executed via data collection rules, or DCRs, directly at the ingest pipeline. By the time the data actually hits the database, it's already stored in dedicated, natively normalized tables, something like ASIM DNS activity logs. Because the data is pre-formatted, reading it is blazing fast. It heavily speeds up the execution of rules and alerts because the system is just reading optimized indices directly. However, it's a very rigid development cycle. It requires strict upfront planning. If a vendor update breaks your DCR expression, raw log elements could literally be dropped or misaligned, and any fixes you apply will only apply to new data going forward, not historically. You are fully trading flexibility for pure performance.
And that brings us to the conclusion, the fully optimized Microsoft Sentinel engine. So, the crucial point is how we bring this all together. We've looked at the physical data layout, the universal translation language, and the exact timing of when to apply that translation. Let's review our finalized architectural blueprint one more time. By combining smart physical storage tiers, hot for active hunting, warm for historical analysis, and cold for immutable compliance, we balance our costs beautifully. By implementing ASIM normalization, we translate that multi-vendor chaos into a single, reliable language. And by making really strategic choices between query time and ingest time parsing based on our performance needs, we create an architecture that isn't just cost-effective, but is a blazing fast security engine ready for anything.
Which leaves us with one final thought. If we architect our Sentinel environment flawlessly today with data that is perfectly tiered, universally translated, and rapidly accessible, what limits the speed of AI-driven threat hunting tomorrow? When you remove the friction of messy, unorganized data, the potential for advanced, automated security operations is truly limitless. Thank you so much for joining me on this explainer, and keep building smarter.